when we say something is a geometric progression, what it means here is that or exponential sequence, right? Something of that nature. So you just have to check the numbers. You see the numbers here, maybe from 1, 3, 9, 7, which whatever numbers that you are dealing with, just check. So how are you going to check that? Your first step is to check the ratio. So what I mean by the ratio here is that you see that this guy here, the second person here, which is 3 divided by the first one, that is 3/1, or maybe this guy divided by the previous one, so 9 over this one. If you see that you are having the same answers for all when you are dividing one by the other, so this is how you divide the second person by the first, and then maybe all the third person by the second, right? Something of that nature. So if you see this thing here, you can see that 3 divided by 1 is the same as maybe 9 divided by 3. That gives me 3, and then 27 divided by 9 is still equal to 3, right? You can see that we are having the answer that we are having, so 3, 3, 3, 3. So if this thing happens, we say that this is what a geometric progression, right? So that ratio is what we call what the common ratio. Maybe we denote that by what small r, right? So you just have to check if this thing doesn't, you are having different answers. Says that maybe you divide this guy by that guy, you had what? So if you divide and then you see that you are having different answers over here, then it means that this is not a geometric progression, right? Just by you identify people by their image, right? And then before you call them by what? Their name. So to identify a geometric progression, you must check this guy first. Okay, if that happens, then now you can guarantee that this is what a geometric progression. So this is what we call what a geometric progression, right? This guy is what we call geometric progression. So I'll explain this in just a few seconds. So what this thing means is that, let's say this n here is the, assuming is the number of people that we are dealing with, right? So A is the first person. What I mean by that is check something here. So here let's say this is the first person, which is 1, so the second person is 3, and then the third person is on 9 here, or maybe the fourth person is also having 27, and so on and so forth, right? So this n here is the number of people that we are dealing with. Okay, the A is what the first person. So what I mean by the first person here, so in this case here, A will be what 1, right? A will be what 1, right? So A is 1, and then your R will be what the common ratio here, this guy here, which is 3. Is that okay? You just need to plug it inside and then move on, right? So this is how you identify what a sequence that is called what geometric progression. Okay, now assuming with this question, assuming that you have been asked to find what the fifth person, so maybe the fifth term, right? So it's your duty to know the type of people that you are dealing with. So what I mean by the people is that the type of the sequence. So what I mean by the sequence here is that, is it a geometric or arithmetic? So here specifically we all know that this is what a geometric progression, right? Okay, so the fifth person, meaning that our n will be what 5, right? N will be 5 here. We know that A is the first person, which is 1, and then 3 is what the common ratio, and then raised to the power n minus 1, right? So n here is 5, so 5 minus 1, so that should give me what 1 multiplied by 3 exponent 4. So here will be what 3 exponent 4. You can break this thing down by what a calculator, or you move straight forward and do that. Okay, so that is how simple you find what a geometric sequence. So what about these two guys? We are having these two guys here, right? So with these two guys here, you can see that this is what we call the sum. So what I mean by the sum here is that, look at something. Assuming we want to know the total number of people, maybe assuming their ages, right? So we want to know the total number of people here and their respective ages by summing everything together. Let's say you have 100 people here, you cannot add them one by one. So there's a way of doing that. So with this one here we are going to have what S, and this S and here, you know that we want to know the sum or the total number of people, their ages, right? So they say you should use this guy. So you must know this thing, right? You must know this thing. That is what A into bracket what 1 minus R exponent n. You see, with this thing you just need to know where A is coming from, where R is coming from, where n is coming from, then you are free to go, right? But you must know everything. So with this guy is one thing that helps us to know the total number of what people, or the ages of the people, or maybe the summations of the sequence that we are dealing with, right? Okay, so we know where R is coming from. R is the ratio, n is the number of people that we are dealing with, A is the first person, which is the first term here. Then we are free to go. You just need to plug them, replace this. Okay, Now look at something here. You can use this one when your area is less than 1, right? Maybe r can never be 2 here, right? R cannot even be 1. Is that okay? R can never be 1 here, so less than 1. So maybe r is at 1/2, right? 1/2, and so on and so forth. So that is where you can use this guy here. But this guy here, the one at the down here, you can only use it when your common ratio here is greater than what? Greater than 1. So tell me in the comment section or in the group here that with this example that I have here, if you want to find the sum of the people or the ages, or this is what I'm calling the people, right? So if you want to find their sum, you want to add everything together at once, which one are you going to use among this? So is it the first one or the second one? So tell me in the comment section below.